Welcome to this pre-class video on alcohols. Well, we know, or you should know, that the general formula for an alcohol is some type of R, and remember R means rest of the molecule. In this class, it's typically a hydrocarbon group, OH. And this OH is what we call a hydroxyl group. So let's go down here and look at kind of a general example. Every alcohol has an OH group, a hydroxyl group on a carbon atom. So this OH is the hydroxyl, and as a result, this is a very special carbon. This carbon is called the hydroxyl bearing. It bears it. It is attached to it, the hydroxyl bearing carbon, and I call it for short HBC. And so what this brings up is that whatever is attached to the HBC allows us to classify the alcohol. And we can have a primary alcohol, a secondary alcohol, or a tertiary alcohol. And a primary alcohol is when you have one carbon attached to HBC, only one. In a secondary alcohol, you have two carbons attached to the HBC. And in a tertiary alcohol, you have three carbons attached to the hydroxyl-bearing carbon. Now let's just do an example. Let's look over here to this molecule on the right. Now I've kind of drawn it in a condensed formula, and I'm going to invite you to take a closer look at this, because if you just glance at it, you may miss the point. This thing is drawn in a condensed form. Really, when you redraw it, and sometimes you should redraw these molecules. It's just to your advantage to redraw them and then analyze them. Take your time. It always works out when you take your time and don't rush. So, there's the OH. Now this is CH3,3C. Well, that means, we know every carbon has 4 bonds. So, the hydroxyl-bearing carbon, which is right here, has to have 4 bonds. And those 4 bonds are to 3 methyl groups and the hydroxyl group. So I've redrawn this, and you can see now that this is the kind of drawn out structure from the condensed structure. Now, take a good look at this carbon right here. This is the special HBC, hydroxyl bearing carbon. It is attached to 3 carbons. Therefore, this is a tertiary alcohol. Again, in every alcohol, the hydroxyl group is attached to a carbon. What's attached to that carbon allows us to classify the alcohols. Now let's look at this one at the bottom. It's a cyclic structure. I know how much you love those, so let's use those as much as possible. You need to first identify the hydroxyl-bearing carbon. Well, it's a skeletal structure, but you know that I'm putting the red dot there. This is where the HBC is located. Now, you need to determine how many carbons attached to the hydroxyl-bearing carbon. Well, one thing you might want to do is add any hydrogens that need to be added. We know going from a skeletal structure to kind of a fully revealed structure, you have to add hydrogens. Well, since there's only 3 bonds shown to this HBC, you know there's a hydrogen attached there. Okay? Well, we've got on the HBC, we've got a OH group, a hydrogen, and it looks like we've got 2 carbons directly attached to the HBC. Therefore, this is a secondary alcohol. Again, we'll do more of this in class and you'll have more practice, but this is kind of where we're going with this. We don't name all the classifications, but alcohols is one of the classifications we need to be able to name. And the good thing is we have these extensive set of rules we've been using over and over to name organic compounds, and we just kind of modify them slightly depending upon which particular classification we're at. Well, this is alcohol, so look at the molecule. Can you tell me that it's an alcohol just by looking at it? Well, yes. It's all hydrocarbon except there's an OH group. There's a hydroxyl group, and therefore there is a hydroxyl. I'm just going to put a dot by this. This is the hydroxyl bearing carbon here. And just for the sake of completeness, I guess, we know that this is what type of alcohol? A secondary alcohol. There are only 2 carbons directly attached to that hydroxyl bearing carbon. All right. Well, the rules of naming alcohols are very similar to what we've had before. We got to find the longest continuous chain, but now that longest continuous chain must contain the hydroxyl bearing carbon, and you want to number the longest continuous chain to keep the hydroxyl bearing carbon the lowest number possible. So I'm going to start here. I think that's pretty obvious. We have to start at an end, at a carbon at the end, and then number from there. So I'm going to go 1, 2, 3, 4. Now we're at a branch point. Now, if you're not paying attention, you're just going to go ahead over here and number this carbon 5. But I'm going to say that's a huge problem, because that would not be the longest continuous chain. To get the longest continuous chain, this has to be carbon 5, this has to be carbon 6. So the longest continuous chain in this molecule has 6 carbons, not 5. That's a common mistake if you're not paying attention to where the longest continuous chain is at. Well, we know that this is the only thing not in the longest continuous chain. This is our old friend methyl that we've used over and over again. And hey, I think we're ready to name this. Again, with this type of molecule, we're going to start with any substituents. So we've got 4-methyl. That methyl group is on carbon 4. Okay, 4-methyl. And we have to locate the OH group. That OH group can be on different carbons. So we have to provide a number to tell us where the OH group is at. So it's going to be 2. 6 carbons is hex N. And if you have an alcohol, it ends in OL. So when you name alcohols, you're going to be looking for OL. You're going to be looking for it, or you're going to be looking to put that at the end of the name. 4-methyl, 2 hexanol. Again, we'll do more of this in class. The last thing I want to do in this pre-class video is talk about a very important reaction of alcohols called oxidation. Again, we've talked about redox. What is oxidation? Loss of electrons. What is reduction? Gain of electrons. Well, you can start with an alcohol and you can react it with what we call an oxidizing agent. Something that causes the alcohol to become oxidized. We're not going to get too deep into how this works, but we want to be able to apply the rules of how you do an oxidation reaction. How do you know you're doing an oxidation reaction? Then you're going to see one of the 3 main suspects. The 3 oxidizing agents we will use in this class is K2Cr2O7, KMnO4, or CrO3. When you see those, you better get ready to do an oxidation reaction. So what happens in an oxidation of an alcohol? Well, I'm not going to give you the so-called mechanism. I'm going to kind of give you kind of what happens. Not typically, this is what happens when you oxidize an alcohol. These 2 hydrogens are going to go away. Don't be concerned. They're in a safe place. We're just not concerned about them anymore. We're not going to draw them anywhere on the product side. They're going away with the oxidizing agents. Don't be concerned. They're okay. They're just not in the alcohol anymore. Okay? Now, the problem is the carbon's lost a bond. The oxygen's lost a bond because the hydrogens are gone. Well, in the end, an oxidizing agent, the result will be having a double bond between the C and the O. So when we draw the product, again, I'm only drawing the kind of a basic product here. This is the basic reaction, what it would look like. You're going to end up with something with a carbonyl group. So we started with an alcohol. These two hydrogens are over here somewhere. Don't be concerned. We're not going to really care about them anymore. Although they're safe, they're gone with the oxidizing agent. And what we're left with is our old friend, the carbonyl. Now, I want us to apply that. So if we look at the molecule down here, we need to focus our attention on the hydroxyl-bearing carbon. This is going to be the now, again, how do you know, I guess the question comes up, how do you know which two hydrogens to remove? Well, you're going to remove a hydrogen on the hydroxyl-bearing carbon, there it is right there, and you're going to remove the hydrogen attached to the oxygen. Those are the two hydrogens that leave town in this reaction, okay? So if we come down here at the bottom, how do I know? How do I know? How do you know which hydrogens are going to leave? Well, it's exactly what I just said. The OH hydrogen is gone. It will leave. I'm going to put an X by it. The hydrogen attached to the hydroxyl-bearing carbon will be gone. Those two hydrogens are going to leave. And then this bond right here between this carbon and oxygen is going to become a double bond, much like we did right above here, right? So, when I draw the product, what's left? What's left? Well, this CH3 group is still up here. And then I've got a C double bond. Oh, there we go. We went from an alcohol to we're going to call this a ketone. We've already know how to recognize ketones, but we don't really name them yet. So we make a ketone from and this ended up actually was a secondary alcohol. So I'm not concerned about you knowing how this happens, just being able to apply it. If I give you an alcohol and an oxidizing agent, what's the product? Or what if I give you the product and say, hey, something was treated with an oxidizing agent, what alcohol did we start with? That could also be a particular type of question that might come up. All right, I think it's a pretty good preview of what we're going to do in class. So I hope this video was helpful.